Hello everyone, my name is Arun Poddar. So today I am going to discuss about unit number 4, design lecture number 32. So the contents that we are going to discuss in this video is the open close principle, the function oriented design and structure charts. Now let us see what is open close principle. So it is nothing but the design concepts which came into existence more in the object oriented concepts. Now what is this here? It is the basic goal is to promote building of systems that are easily modifiable. That is, building the systems or software systems which can be easily modified. So model is open for extension, means its behavior can be extended to accommodate new demands placed on this model due to the change in requirements. Even if the requirements change, it will be easy for making changes in the model. So that is the open closed principle. So a model is closed for modification means that existing source code of the model is not changed when making enhancement. Okay, so model will be open for extension, that is it will be open for any changes that you make. It allows addition of code but disallows changing of existing code, which means we cannot modify the existing code, but we can allow addition of code. So the benefit is that code changes involve heavy risk. Okay, so also programmers typically prefer writing new code rather than modifying the old one, because even if you return a 50 lines of code and if you want to modify the entire 50 lines, it will be very difficult. So rather than modifying the old one, programmers will prefer rather writing a new code above 50 lines. So if the 50 lines of code is there, if you want to add new code, the program will prefer to write the new code after the 50th line. So consider an application in which client object interacts with the printer object of class printer1 and invokes the necessary methods for completing its printing. Now in this design, the client directly calls the methods on the printer object for printing something. So suppose system has to be announced to allow another printer to be used by the client. So new class printer2 will have to be created and the code of the client class will have to change and allow using object of printer2 type. Okay, now it does not support the open close principle. So in this design we create an abstract class called as printer that defines the interface of the printer and specifies all the methods of the printer. Now in this design, printer2 will be added and it is added as another subclass of type printer. So this is the class diagram for subtyping. So here the client will call the printer. So printer has two subclasses, printer1 and printer2. Function oriented design structure. So for a function oriented design, the design can be represented graphically by structure charts. So the structure of the program is made up of modules of that program as well as showing the interaction between them. So it is represented graphically. So model is represented by a box with the model name written in the box. Arrow from model A to model B represents that model A invokes model B. B is called subordinate of A and A is called superordinate of B. So the arrow is labeled by the parameters S by L, B as input and parameters returned by B as output with direction of flow. So as you can see here, consider the structure of the program. There is a program, as you can see here. We have declared a variable integer sum and a variable. There is a function called as read nums, sort and scanf function. There is a sum function and a printf function. So this is the sort function. It will add the first n numbers of A. So the structure chart for the sort program is as shown in the figure. As you can see here, there is a main function, main controller. Okay, so there are, as you can see here, there is a parameters A and N. So A is an array, N is the number of elements. First, the parameters are read nums, that is a scanf function will read all the elements as well as the number of elements by calling the read function, and it will again return to the main function. And then once it has read all the elements as well as number of elements, so that parameter is again sent to the sort function. Okay, so sort function will sort all the elements and will return that array. Okay, so it will sort all the numbers. Same with again it will send the parameters, that is an array A and the number of elements. So while sending array and n elements to add n function, it will calculate the sum of all the elements present in array A and it will return the sum. Okay, now here two values have been returned, the sum from add n functions and an array containing the sorted numbers from the sort function. Now the sort function uses the switch cases by sending the parameter x and y, and again it will return x and y. Iteration and decision representation. So the same can be represented in form of iteration and decision representation. Now there are situations where a designer may wish to communicate certain procedural information like major loops and decision. Okay, so major loops cannot be represented in procedural information, so such information can be represented in the structure chart. So consider a situation where module A has subordinates B, C, and D, and module A repeatedly calls the modules C and D. Okay, so it is calling repeatedly C and D. So this can be represented by a looping arrow around the arrows joining the subordinates C and D to A. So you can see here C and D are joined through an arrow to A, which means that A is continuously calling C and D. All the subordinate modules activated within the common loop are enclosed in the same looping arrow. So major decisions can be represented similarly. So for the examples, if the invocation of module C and D in module A depends on the outcome of some decision, then this is represented by a small diamond in a box for A. So as you can see here, the same representation can be represented by using a small diamond, okay, with the arrows joining C and D coming out of the diamond. Now modules in a system can be categorized into few classes. Okay, so modules that obtain information from their subordinates will pass to their superordinate, it's called as input module. But the modules which take information from the superordinate and pass it to their subordinate is called as output modules. So it typically used for input and output data. Okay, so the modules that transform data into some other form are called as transform modules. So in this video we have discussed about what is open close principle, function oriented design using sort program, what is structure charts. Thank you.